Okay, we're talking about Encore, lesson 82 and 83. We're going to combine the two of those today, so you're going to have to forgive me switching from one slide to the next. But 82 and 83, I think, will go hand in hand because they're pretty short lessons, both of them. They're kind of review. 82 is based on the geometry that we're doing. We've been dealing with area or surface area, and what we're going to do now is look at volume. The formula for volume is based on the same thing that we talked about before, which is base times height. But now I need the entire base times my height. So what I need to actually solve is volume equals length times width times height, or the total base times the height. I now have 3 dimensions, which means my answer is going to be cubed. In this case, meters cubed. I'm going to do the first one for you here. So finding the volume, base times, or length times width, excuse me, which is going to be 5 times 4. So this is going to be 20 meters squared. So in other words, this is 5 times 4. Now I have the whole area of the bottom, and then I'm going to take that area and I'm going to stretch it up into a third dimension, 2.5 meters. So I come over here and I have 20, I'll write this out here. 5 times 4 times 2.5. In other words, 5 times 4 would be 20 times 2.5. Write my half there. So 20 times 2.5, I'm going to go ahead and write 20 times 2.5. And we'll just write that out. 5 times 0 is 0. 5 times 2 is 10. Bring down my 0. 2 times 0 is 0. 2 times 2 is 4. Adding them together, and I get 0, 0, 5. Bring down my decimal. I have 1 digit to the right in my problem, so 1 in my answer. The answer is going to be 50 meters cubed. So let me show you one more of those. In other words, as I erased everything, I come down here and I need to find the area of the base and then multiply that by the height. So my volume is going to be length times width times height, or total base times height. So let's do 4.5 times 2 times 3.5. 4.5 times 2 will give me 9 times 3.5. Well, I'm getting into fractions here. I'm going to go ahead and write it out for you. 3.5 is the same thing as 3.5. I'm going to multiply that by 9. 9 times 5 gives me 45. 9 times 3 gives me 27. Plus 4 gives me 31. 1 digit to the right of the decimal in my problem. 1 in my answer. 31.5 centimeters. Cubed. It's cubed because it's volume. And you might say, well, how can I go and mentally check that to see if I'm anywhere in the ballpark? 31.4. Well, what if I just take this and we'll say 4.5? That's pretty close to what, 5, right? So that's going to be 5. That's going to be 4. That's going to give me 20. 20 times 2 is going to give me 40. So 31.5 is somewhere in the ballpark of 40. I know it's not that close as a number, but if I had 315, I'd be way off. So I can check that my decimal place is in the right area just by doing a little rounding and multiplying mentally. So if I move on to the next one here, let me go ahead and step out of frame for just a second. And we're going to find 83 right here. Now this is still dealing with figures, whether they're triangles, trapezoids, anything like that is basic geometry, but I'm now using a grid to help myself measure certain things. That's basically all I'm doing here. So I remember X comes before Y. If I need to verify, I've got an X and a Y built into my grid there, but also remember that you run before you jump, and the X comes before Y in the alphabet. Either one will work. So if I have -3, 3 for J, I start at X and I go to -3, and then I match it going down -3. We're going to call that J. K is -3, +5. So again, I start with X and I go to -3, and my next one, Y, will be a +5. And I want to label that K. You might say, well, why am I labeling it? That's not really important. It will be for our next step here. And then finally for L, I want +5 on the X first, and then +2 for the y, right here. And we're going to call that L. So now I have J, K, and L, and I can connect them. And when I connect them, I want to know what the length of JK is. Well, which one is JK? Right here, from J to K. I can either count them and go 1, 2, 3, 4, 5, 6, 7, 8. It is 8 units. Or I could look at absolute value. If you're up on your absolute value, this is the absolute value of -3 plus +5, or the absolute value of 5, because I'm looking at distance on a grid. Absolute value of -3 is 3, plus absolute value of 5 is 5, which will still give me a total of 8. Let's look at one more, just as an example. I have a trapezoid now, the funny looking trapezoid. It's WXYZ. W is going to be -2, and -2 is on X first. X before Y in the alphabet, run before you jump. All of those things still make sense. -2, -3. Label it W. X is going to be -2, +3. Let's call that X. Y is going to be +3, +5, and we'll call that Y. And Z is going to be +3, -3. Z. Now, I can connect them. Does it really matter in which order I connect them? No, it doesn't. As long as I make sure that they're all connected and they're all in the right space, and I look and I say, yes, that is indeed a trapezoid. So I want the length of WZ, which is right here, and I can either go from -2 and count it, 1, 2, 3, 4, 5, or again, if you're up on absolute value, if not, this might confuse you, just count them. But if you're up on your absolute value, it's the absolute value of -2 plus the absolute value of +3. Absolute value of -2 is 2 plus absolute value of 3 is 3, which does give me 5, just like this gave me 8. Okay? So again, make sure that X comes before Y. X is the first number. You run before you jump. Label all of your diagrams. Use your labels. Use your unit rates. It's very important. That's how you're showing your work. Because when it all comes back to it, you can say, well, there's what I'm looking for. I'm just going to count it.